Hello, beta. Good afternoon. The recording is on now. Let's continue with our discussion.
Good afternoon, sir.
Good afternoon. अच्छा बेटा, सबसे पहले एक डाउट था किसी को. कैन यू रिपीट दैट डाउट प्लीज? Is that solved, beta? The doubt is solved? Okay, doubt is not there. So shall we continue with the presentation then?
सर वो प्रीवियस क्लास वाला डाउट था.
हाँ बेटा, वो क्या डाउट था बेटा, बताओ मुझे.
सर ये जो 5th क्वेश्चन है एक्सरसाइज 30 का.
बताओ बेटा, SHA क्या है स्टार का?
SHA है सर 258 डिग्री 50.4.
258. Okay, let me see. ओके, तो आपको जो स्टार मिल रहा है दैट इज कैनिस मेजोरिस.
यस सर, जो 265 के बाद है वो कैनिस मेजोरिस है, और जो इसमें डेली पेजेस में उसमें सीरियस है.
ओके, कैन एनीबॉडी टेल बेटा व्हाई दिस डिफरेंस?
और ऑलमोस्ट सेम SHA एंड डिक्लिनेशन है सर.
या दैट्स राइट.
सर कहाँ मिल रहा है सर, मेजोरिस कहाँ मिल रहा है?
बेटा जो अपना स्टार टेबल है पेज नंबर 268 पे, नॉटिकल एल्मनैक, जस्ट ओपन अप पेज नंबर 268.
Sir, maybe same names.
ओके सर 268.
आ गया बेटा. अब इस टेबल में जो स्टार्स दिए हुए हैं दे आर गिवन इन इंक्रीजिंग ऑर्डर ऑफ SHA. Right. So the SHA which we are looking at is 258.
पेज नंबर 272 सर.
Right. So 258 SHA is on two pages, 272 also, 273 also.
यस सर, लेकिन वो अप्रैल का है सर, डेट इज 30th अप्रैल.
Right. So that's why you are looking on the left hand side page. Huh?
यस सर.
वो सर सीरियस को भी कहते हैं ना, कैनिस मेजर्स, इसकी दूसरी कॉन्स्टलेशन में इसका नाम ये होता है ना शायद.
Right, that's right. अब बेटा ध्यान से सुनो, जो ये पेज 268 वे टेबल दिया हुआ है इसमें आपको स्टार्स के नाम अलग अलग दिखेंगे. लेफ्ट साइड पेज पे स्टार्स के नाम अलग हैं, राइट साइड पेज पे स्टार्स के नाम अलग है वो सेम स्टार ही. नाउ व्हाई दीज नेम्स आर डिफरेंट? इफ यू सी जनवरी टू जून जो उसकी डिटेल्स हैं वो लेफ्ट साइड वाले पेज में है. जुलाई टू दिसंबर जो डिटेल्स हैं दे आर ऑन द राइट हैंड साइड पेज. राइट. सो it is the same star which is given on both the pages, but why the name is different is जो लेफ्ट साइड वाले आपकी लिस्ट है that list is of the Latin names, Latin, एंड जो राइट साइड वाले पेजेस में आपके नेम्स दिए गए हैं these are English names. Now obviously we are more connected to England, so we are using English names for our purpose. So आप जब इस टेबल में से स्टार का नेम पिकअप करते हो, irrespective of whether it was the month of January or December, आप राइट हैंड साइड पेज वाला स्टार नेम ही पिक करोगे. The reason is that we use English names, we do not use the Latin names. Okay beta, is it clear now?
यस सर, क्लियर.
ओके, ऑल राइट। ओके, और कोई डाउट बेटा अभी तक?
सर फिर इसमें जो ये लेट्स से अपन कोई एसएचए कैलकुलेशन में एग्जैक्ट सेम आता है, लाइक विल पिक एनी ऑफ द स्टार, सीरियस ही ले लेते हैं सर, तो इसमें जुलाई के मंथ में 258 डिग्री 47.8 है और
राइट
कैलकुलेशन में 258 डिग्री 47.8 आ गया।
राइट।
और सर ये इसमें इंस्टेड ऑफ जैसे लाइक सॉरी ये इसका लैटिन नेम वाला आ गया करेक्ट, कैनिस मेजोर इसका 258 47.4 आया जनवरी में,
ठीक है बेटा।
एग्जैक्ट कैलकुलेशन में ये आया, तो फिर भी हमें ये राइट साइड वाला लेना है।
राइट बेटा, हमने नाम राइट साइड वाला ही उठाना है क्योंकि हम इंग्लिश नेम्स को यूज करते हैं। वेदर यू कॉल इट कैनस मेजोरिस और यू कॉल इट सीरियस, इट इज वन एंड द सेम थिंग।
ओके, ओनली द
गंगाधरी शक्तिमान।
नेम इज डिफरेंट, द थिंग इज सेम।
हाँ, गंगाधरी शक्तिमान है।
ठीक है, थैंक यू सर।
ओके, ऑल राइट। और बताओ बेटा, और कोई डाउट? Okay, so shall we proceed ahead now, beta? Okay, all right. So let's proceed ahead. I was familiarizing you with the almanac. We had seen the daily page and we were on the increment table. Let's move on to the increment table and continue from there. Beta, is this familiarization almanac okay, or shall I cut short and proceed ahead? No sound? Okay, let me continue with the increment table. If you have forgotten anything, you will revise and refresh in your mind. And it is actually important that you understand all these terms very well before you go into question solving.
Sir, increment one is okay. Sir, can you please spare some time for this Polaris Polestar tables?
Okay, I'll explain that, beta. I'll explain it to you when we do the Polaris observation. मैं आपको explain करता हूँ चारों table.
Yes, sir.
We will do X meridian tables when we do X meridian method, and we'll do Polaris table with Polaris. So let me continue. I'll continue with the increment tables also. Let me show it to you. Then we can proceed ahead. So just give me a minute. I'll set up the presentation. Beta, you can mute your mics now.
Let's now go into the increment table. You can see the screenshot of increment table for 46 minutes and 47 minutes. Now you see in the increment table, the first column gives you the seconds. So for each minute and every second, you can get the increment of GHA for all the celestial bodies. The next column after the time column is the sun and planets column. So you see the increment of the sun and planets given in this particular column. Let's say, for example, For 46 minutes and 10 seconds, the increment of the GHA of sun or planets is given as 11 degrees 32.5 minutes. Now, after sun and planets, you have the Aries column. The second data column is the Aries column, and you can see the increment of Aries here. Why two separate columns for sun and Aries? That is because the rate at which the sun and Aries change their GHA is different. So just for your information, the sun
Beta, you can mute your mics. I think somebody's mic is on. Whose mic is on, beta? Can't see that here. Okay, let's continue.
changes its GHA at a rate of 15 degrees per hour, and Aries changes its GHA at a rate of 15 degrees 2.5 minutes. That's why the different columns, and you should be careful when you are picking up the increment values from here. You should pick up the value of the increment from the appropriate table as per the celestial body which you are looking for. In case of stars, it will be picked up from the Aries column, and in case of sun and planets, it will be picked up from the sun and planets column. The difference is evident if you see for 46 minutes and 10 seconds, the value for sun was 1132.5, whereas for Aries is 1134.4 minutes. The next column is the increment column for the moon, and you can see the increment values. The rate of change of GHA for the moon is different. The rate of change of GHA for moon is basis 14 degree 19 minutes in this particular table. That is just for your information. So you can see for 46 minutes and 10 seconds, the increment for moon is 11 degrees 1.0 minutes. So these three columns giving you the increment for the GHA of sun, planets, Aries, as well as moon. Now coming to the next part of the table, you can see the next part of the table provides you the increment for V corrections and D corrections. So the V correction and D correction which were given in the daily pages or the day pages of the almanac were for 1 hour. Now for any particular minute and second, you can find out the increment of V and D correction from here. Let us say, for example, if the V or D correction was given as, let's say, 7.4 minutes, V or D correction value was 7.4 minutes for 1 hour. Then in case of 46 minutes, the increment for that value would be 5.7 minutes. So you can see it here. For a hourly value of V or D, you have the increment which is applicable to this specific minute. So for 46 minutes, the increment for 7.4 D or V value would be 5.7. So this is what is used. The V correction is used for calculating the exact GHA, and the D correction is used for calculating the exact declination at a particular hour, minute, and second.
Okay, this is not required. These index we have done already. Okay, let's go into azimuth now. Calculation of azimuth using the ABC method.
Let's now refresh the calculation of azimuth of the celestial bodies using the ABC method. Now, in this method, we calculate the three components A, B, and C, and this helps us to calculate the azimuth of the body. The azimuth is basically the bearing or the direction in which the body is. A is given by tangent of latitude divided by tangent of P. Latitude will be given to us in these questions, so that same latitude is used here, and the value of P is obtained from the LHA. This P is basically angle P of the PZX triangle, which is made on the celestial sphere. And this P is either equal to LHA or it is equal to 360 minus LHA. Now, in which case it is equal and in which case it is 360 minus LHA? If the value of LHA is less than 180, the value of P is equal to the value of LHA. And if the value of LHA is greater than 180, the value of P is 360 minus LHA. In any case, the value of P will never be greater than 180 degrees. Now, once you calculate the magnitude of A, we have to give it a name. The naming is either north or south. Now, let's understand how the naming is done. This A factor is named opposite to latitude if angle P is less than 90 or if the value of LHA is greater than 270 and less than 090. So you can remember any of the conditions which is more comfortable and convenient, easy to memorize for you. The factor A will be named opposite to latitude if the value of P is less than 90 or if the LHA is greater than 270 and less than 090. And it is named same as latitude if the value of P is greater than 90 or the value of LHA is greater than 90 and less than 270. So as mentioned earlier, you can remember any of the two conditions. Either you can correlate it with the value of P. P less than 90, it will be named opposite to latitude, and P greater than 90, it will be named same as latitude. Or you can correlate it with the LHA of the body. If the LHA is greater than 270 and less than 90, it will be named opposite to latitude. And if the LHA is greater than 90 and less than 270, it will be named same as latitude. Now, you will observe that in most of the questions, the condition which will apply will be the first condition, condition number 1. That is named opposite to latitude if P is less than 90 or LHA greater than 270 and less than 90. So in most of the questions, you will have the first condition given to you. A doubt may arise in your mind that what if the value of P is exactly equal to 90? Or in other words, the value of LHA is exactly equal to 90 or 270. So how are we going to find the direction of A? Now, if the value of P is equal to 90 degrees, the A value in this formula, you can see here that the value of A would become 0. You can understand it very easily. Tangent P can be broken down as sine of P upon cos of P. The cos of P component will come in the numerator, and in case P is equal to 90, cos of P becoming cos 90, which is equal to 0, will convert the whole factor to 0. So the A factor or the value of A would be 0 in that case. So you will not need to name it either opposite to latitude or same as latitude. So this was the formula for A. Now let's proceed ahead and see the formula for B. Now B is calculated using the formula tangent of declination divided by sine of P. Now P, as I told you, will be calculated from the LHA of the body. If LHA is less than 180, P is equal to LHA. If LHA is more than 180, P is equal to 360 minus LHA. How would we obtain the LHA of the body? It can be easily obtained from the GHA, which is given in the almanac. You will obviously be given a particular time on which the azimuth is required. So for that time, you can get the GHA of any celestial body, sun, star, planets, and moon. For all these bodies, the GHA is obtainable from the almanac for every day, hour, minute, and second of the year. So you obtain the GHA of the body from the almanac. You apply the longitude of the observer, which is given in the question. And when you apply the longitude to GHA, you get the LHA of the body, and that gives you the value of P. The numerator contains declination. Declination is obtained directly from the almanac. So as I told you, the date and time of the observation is provided to us in these questions. So with that date and time, we can enter into the almanac and get the declination of any celestial body. The declination as well as the GHA of all the celestial bodies, sun, stars, planets, and moon is obtainable, available to us in the almanac information. So this is the formula for B, and the naming for B is very, very simple. It is always named same as declination. So once you calculate A as well as B, now you can combine them to obtain the value of C. Now how do you combine them? C is obtained either by A plus minus B or B plus minus A. Now, which of these is to be used in a particular scenario? If the value of A and B is of the same name, we have named both of these factors. A is named basis this criteria, opposite to latitude or same as latitude. B is also named same as declination. So if you find that both A and B are of the same names, you add them and obtain the value of C. If A and B are of the opposite names, then we subtract the smaller one from the bigger one and retain the name of the bigger one. So same names are to be added, opposite name, the smaller one, is to be subtracted from the bigger one. The naming of C is done if both A and B are of the same name, the C is also of the same name. And if A and B are of the opposite name, C gets the name of the bigger value, whichever is greater between A and B. So this is the formula with which we can obtain C. Once C is obtained, then we can use it in the azimuth formula. We will just see the azimuth formula in the coming slide. Now, another doubt which may arise in your mind is that we do these calculations using the scientific calculator. So sometimes if you want to write down these values to how much accuracy we should note these values down. So value of A, value of B, and then value of C. You can do that in the calculation. The entire formula can be solved in the calculator itself, giving you the maximum accuracy possible. But for writing down in your answer sheet, you can write these values up to 5 places after the decimal. So when you are writing them down, no need to write down the full value. That will be unnecessarily lengthy and complicated. We will get our required accuracy by going to 5 places after the decimal, and the accuracy would be sufficient for our purpose. Now, once the value of C is obtained, then we can use this formula. Tangent of azimuth is equal to 1 by C into cos of latitude. C is what we have just calculated from combining A and B, and latitude is given to us in the question. So using these two values, we can obtain the azimuth of the body. So this is the last formula which we use after A, B, and C. Now, when we calculate the azimuth using this formula, important thing to remember is that azimuth is obtained in the quadrantal notation. It is not obtained in the 3-figure notation or true notation. It is obtained in the quadrantal notation. Now, in quadrantal notation, whatever value you obtain has to be prefixed by either north or south, and it has to be suffixed by east and west. You will have the north-south name before the value, and you will have the east-west name after the value. So the formula is going to give us the value or the magnitude of the azimuth. How do we now decide whether it is north or south in the beginning and east or west in the end? Or in other words, how do we decide what is the quadrant in which the azimuth lies? Now this is also very, very simple. The north-south value to be written in the beginning is decided by the name of C. Remember, I told you when we combine A and B, if both are of the same name, the name of C is also same. The name is same as A and B. If A and B are of the opposite names, C gets the name of the bigger value. So whatever is the name of C, the same name is used in the beginning before the value, either north or south. And the ending part, east and west, is decided by the LHA of the body. So we had already calculated the LHA of the body for finding the value of P to be used in the formula. So this value of LHA tells us what alphabet has to be used in the end, whether it will be east or west. If LHA is less than 180, it will be west, and if LHA is greater than 180, it will be east. This is because LHA or local R angle is a westerly measurement. It is measured westward from the observer meridian. So if the LHA is less than 180, it denotes that this particular body is west of the observer. And if LHA is more than 180, then it denotes and indicates that the body is east of the observer. So this is how we decide the quadrant in which the azimuth lies. Now, when we work with celestial navigation questions involving R angles, by R angle I mean the local R angle LHA, Greenwich R angle GHA, or sidereal R angle SHA. You may sometime be faced with a tricky situation. What happens during calculation that the value of these R angles sometime goes into negative, and in other cases the value may go beyond or more than 360 degrees. Now, what is to be done in those cases? Now, sometime candidates get confused of how to get these R angles correctly. So that's why I always emphasize it. The value of R angles, whether it is Greenwich R angle GHA, or local R angle LHA, or sidereal R angle SHA, you can also consider right ascension. Right ascension is something which is opposite to SHA. SHA is measured westwards. Right ascension is measured eastwards from the celestial meridian of Aries. All these are R angles. Now their value always remains between 000 and 360. The value of R angle will always lie between these two figures. Now, in any of the calculation, if you see that the value of R angle has gone outside this range, that means either it has become negative, less than 0, or it has become greater than 360. Now, how to bring it back? You can add or subtract 360 degrees any number of times as you require to bring it within this range. So if the value of R angle is minus 60, you have to add 360 to it, and you will get the answer as 300. If the value of R angle is, let us say, 740, it has gone beyond 360 range, it is more than 360, you subtract a 360. If after subtracting 360, still the value remains outside the range, you can subtract 360 degrees again. That is why you see it is mentioned any number of times. 360 degrees can be added or subtracted any number of times till you get the R angle value between these figures of 000 and 360. So very important relationship. Please keep in mind that always 360 is to be added and subtracted. We do not add 90 or 180 or 270. Any of these figures are not added or subtracted, otherwise the calculation will go wrong. We always add 360 and we always subtract 360 only. So if you keep this in mind, you will not get stuck with the R angle calculations, and you will get the right answers. Now let's refresh the calculation of amplitude. Amplitude is basically the azimuth or bearing of a body when it is on our horizon, or you can say when it is rising or setting. Now, the formula for amplitude is sine of amplitude is equal to sine of declination divided by cos of latitude. So in these questions, the latitude is provided to us in the question, so it can be straight away picked up and used, and the value of declination is obtained from the almanac, and just by a single step formula we obtain the value of the amplitude. Now we have to be careful that the value of amplitude which we obtain is obtained in a special format, and that format is You will have a east or west in the beginning, and you will have a north or south in the end. We do not use this type of format in any other calculations. The format which is generally used in the quadrantal notation has the north-south in the beginning and east-west in the end. But in the calculation of amplitude in this particular formula, you will have the east-west coming in the beginning and north-south coming in the end. Now, when you get the value of amplitude from the formula, you get the magnitude. Now, how to find out the name, whether we should put east or west in the beginning, and whether we should put north or south in the end? How is this to be decided? This is also very simple and easy. Now, whether we should put east or west in the beginning is decided by whether the body is rising or setting. In case of rising, it will obviously be east. All the celestial bodies rise on the eastern horizon. And in case of setting, it will be west. All the celestial bodies set on the western horizon. The north or south to be put in the end is decided by the declination of the body. Whatever is the name of the declination, the same north or south indication is to be put at the end of the amplitude. So this is the amplitude formula and the related information about how it is to be named. Now, in amplitude questions, usually the time of observation is not provided to you. In the azimuth calculations, I told you that date and time is provided in these questions because the azimuth will keep on changing as the time passes. But for amplitude questions, usually the time is not provided to you. So how do we obtain the declination of the body? Because for declination, we require the time. So what we do is, we first obtain the LMT of rising or setting of the body from the almanac. So we obtain the LMT of rising or setting from the almanac. Then we apply the longitude and time. dr longitude is provided to us, so we divide it by 15. That gives us the longitude and time, and we apply it to the LMT to obtain the GMT of rising or setting. Once the GMT is obtained, with that GMT we can easily enter into the almanac and get the declination of the body, and this can be then applied, used in the formula. So these are the steps which are involved in the amplitude calculations. Practically, we only use the sun for amplitude purpose. No other celestial body is practically used for amplitude calculation. Other bodies are stars, planets, and moon. Stars and planets, why they are not used is because they are point objects, and usually we are not able to clearly observe them when they are rising or setting, or they are close to the horizon. So they being point objects, difficult to observe when close to the horizon. So that's why not used frequently for amplitude observations. And in case of the moon, why is moon not used for amplitude? In case of the moon, when you see the moon rising or when you see the moon setting, by the time we see the moonrise or moonset, the occurrence has already occurred, means the moon has already come above our rational horizon. By the time we see the moon, it has already attained some positive altitude. Now, how is that possible? When the moon rises and we see it immediately, how has it attained a positive altitude? The reason lies in that we observe the moon using the visible horizon. but the amplitude is taken basis the center of the moon on the rational horizon. Now, in case of the moon, the rational horizon is below our visible horizon. So that's why when the moon comes on the visible horizon, it has already crossed the rational horizon and its amplitude is practically not possible. The second difficulty which we face with the moon is that because of the phases, the shape of the moon keeps on changing. Sometime it is gibbous, sometime it is crescent. It could be a full moon day or new moon day. So if the size is anything less than half, it will be difficult to get the exact bearing of the center of the moon. So that is another difficulty which we face while taking the amplitude of the moon. Now, just to make it a little more clear in your mind about the amplitude of moon not being practical, you can see this is a calculation picked up from the Principles of Navigation book from the altitudes chapter. You can see that the observed altitude of the moon's lower limb on a particular day was 0 degrees. This basically signifies the moonrise. Now, if you apply all these corrections, the dip correction, then the refraction correction, then the semi-diameter, and then the parallax correction. The parallax correction, you will see that the true altitude of moon is already 28 minutes. So moon had already achieved a positive altitude. By the time you are able to see it, it appears on your horizon, you are already having the moon at 28 minutes of altitude. So that's why amplitude is not possible. Amplitude is taken at the instant when the true altitude of the body is 0 degrees 0 minutes. That means the center of the body is on the horizon. You can easily understand it from this particular diagram also. You can see the Earth on the left hand side, the big circle representing the Earth. We have an observer on top of the Earth, and it is having a certain height of I. So it is represented by this vertical line right now where the laser pointer is. Now from the eye of the observer, if you draw a tangent to the surface of Earth, this gives you your visible horizon. This is the visible horizon. From the eye of the observer, if you draw a tangent to the surface of Earth, this gives you the visible horizon. And the rational horizon, if you consider in this diagram, the rational horizon passes from the center of the Earth. So this horizontal line which you see, passing from the center of the Earth, every point on which is 90 degrees away from the zenith of the observer is the rational horizon. So you can see it is labeled as rational horizon, and the slanting line is labeled as visible horizon. Now we have compared the sun and the moon in this particular scenario, and moon is much closer to the Earth as compared to the sun. And you can see when the moon is rising in the morning, coming up from the eastern horizon, you see that it will first cross the rational horizon. After crossing the rational horizon, later on, it will reach to our visible horizon. So by the time we are able to see the moon, it has already attained a positive altitude. So telling us that the amplitude in this case will not be possible. Amplitude should be taken when the center of the body is on the rational horizon. Now let's compare it with the case of the sun. You can see the sun is much farther away from us as compared to the moon. So we have the sun much farther away, And you can see at this particular condition, the sun has already crossed the visible horizon. That means the sunrise has already occurred and it will come to the rational horizon a little later. Now, this is exactly the reason that when we take the amplitude of the sun, the amplitude is taken at that instant when the lower limb of the sun is 1 semi-diameter above the visible horizon. So when the lower limb of the sun is 1 semi-diameter above the visible horizon, that is the time when the center exactly lies on the rational horizon and the amplitude can be taken.
Okay, so I hope beta everything is clear up to here. Any doubts you are having in any of the topics which we discussed?
Yes, sir, clear.
Very good.
सर एक चीज पूछनी थी बस वो जो इंक्रीमेंट टेबल में ना वी एंड डी करेक्शन जो है 2 वैल्यूज दी है ना उसमें
Right, beta.
तो सर वो क्या है वो मैं थोड़ा स्किप हो गया था ये चीज
Okay, beta, let me go to the increment table. This is the one, beta. Which values are you talking about?
राइट साइड में जो है हाँ ये वी एंड डी करेक्शंस
Okay, there are 3 columns, right?
यस सर
So why these 3 columns? Is that the doubt, beta?
तो नहीं सर उसमें 2 वैल्यूज है एक वी की और एक डी की है
Okay, okay. Beta, this table is applicable for both V and D. If you want to find the V correction increment, the same table is used. If you want to find the D correction increment, the same table is used. So whether it is V or D, you can use the same table to find its increment to be applied.
ओके सर तो इसमें जो दो एक ही कॉलम के अंदर 2 वैल्यूज दी है ना ये मैं
Okay,
पूछना
beta. Okay. You
एक
see
V
this
है
daily
और एक
page.
D है ये
I'll explain it to you. You see this daily page.
ओके
Now in this daily page, let's go one page back. Okay, you see the V correction of the moon is 7.7 here, right? Are you able to see beta? 00 hours?
हाँ सर देखा ओके
Okay, so this is 7.7. Now this 7.7 is for 1 hour. This is for 1 hour. Now let's say you are trying to find it for 46 minutes.
ओके
Now for 46 minutes, you will have to go to 7.7, which is here, and see its increment. It will be 6.0 in this case. So
Okay.
you will be adding only 6.0 minutes in your GHA.
ओके सर
Okay, beta?
ओके ओके
Okay. और बेटा और कोई डाउट अभी तक? Very good. That's great. So now the stage is set for us to jump into the site calculations. So I would like you to go through what we did today. The amplitude, azimuth, almanac, V correction, D correction, altitude correction. All these things you can refresh in your mind, turn the pages of the almanac so that they get settled in the mind. And next lecture onwards, we are going to start off with site calculations. So maybe Marpas and long bicron, and then moving on to intercept, X meridian and Polaris. So that's next in the line, and we will start that from the next lecture onwards. Once that is done, then we are ready to go for plotting. That will be the plotting of sites, staggered observations, simultaneous observations. Okay, so that was all for this session, and I'll see you tomorrow with the Marpas observations. So anything else from your side, beta? Okay, great. So then we call off this session. See you guys tomorrow.
Okay, sir. Thank you.
Okay, beta. I thought everybody is asleep. So no, you are awake. Okay, see you. Bye bye.